Good morning, everyone. Thank you very much for coming. I'm Chris. I'm a staff engineer at GridPoint, where I designed and helped build Plox. So I'm going to tell you a little bit about why we built it. We, at GridPoint have lots of data that we collect, and we needed graphs to be able to display them. So we wanted, on top of that, our graphing needs were relatively custom, and we wanted to throw together lots of weird graphs and kind of mix and match things. And so some of the ready-made solutions didn't quite work for us. We wanted low-level control over how things were being drawn. So that's why we decided to build this. So let me tell you a little bit about how it works, and I'll show you some examples of how to use it. So what is Plox? Take some time to digest this description here while we look at some fancy examples. This graph here is updating once per second. It has the x-axis labels moving right to left as time passes, while new data is being continuously added to the front of the graph. I particularly like how I had control, very precisely over where the x-axis labels are being drawn, and how they move and stuff. And we can also see how occasionally there's a randomly sized colored dot being added, just to shake things up. Here we have some basic trig functions being graphed. But we're updating a parameter 60 times per second, so we get a much smoother looking animation. We're customizing the colors here, the line styles, whether or not we want to draw points alongside the lines, each independently of the data set being graphed. Here's a very similar, it's the same graph, but instead of a pair of lines, we're using bar charts instead. I think the styling could use a little work on this one. I kind of threw this one together last minute, so sorry about that. So what is Plox? Server-side rendered SVG graphing components for Phoenix and LiveView. Let's break that down so that we fully understand it. We say server-side here because it's not JavaScript. We decided early on at GridPoint to be as JS-free as possible, to build as much in pure LiveView as we possibly could get away with. So it's honestly been really nice staying in pure Elixir land for almost everything we do. Next, HTML and SVG, because Plox generates plain HTML and scalable vector graphics outputs. It doesn't use anything else like Canvas or WebGL or any other graphics rendering techniques, right? And finally, we say Phoenix and LiveView because it just means that it's built out of a set of composable HEEX function components for use in standard Phoenix apps or LiveView apps. Again, these are just standard HTML and SVG tags, so they're optimized for being served by Phoenix, and you get the powerful minimal live update diffs from LiveView if that's what you're using. So, if you'll please indulge me as we go on a small side quest for a moment to talk just about designing HEEX components and how we came to the sort of core tenets that we came to while designing Plox. Let's try building this simple button pictured here with the click me on it. This component here, as you can see, it's a HEEX function component. It takes a label and action attribute. They're both set as strings. It renders a simple HTML button element, and it bakes in this class of button into the component, and it passes on the action attribute onto the PHX click binding. So this is for use in a LiveView app, just as demonstration. See here how we use it in a HEEX template. It's simple, right? Not much to it. We give the label, we give it the label that we want to display and the name of the LiveView action we want to happen when clicked. But maybe it has some problems, right? It's not composable. It only supports string labels. What happens when I want to add an icon on the button? What happens if I want to style that text, in different ways? I want to make the me bold. It has limited feature set support here. It only supports LiveView right now, and it only supports being inside of a parent LiveView What happens when we want to use it, as a form button? Or what if we want to trigger JS commands, LiveView JS module? Or what if we want to send a param to the server? Or what if we're inside of a live component? We have to attach that phx-target attribute so that the event goes to the right live component, right? So, and it's not customizable on top of that, right? It just has this hard-coded class and doesn't let you do anything else. So it's a good start, but let's do better. So, a button with more features. So we need to support icons. So let's see how we can go about doing that. So here we've added the new optional icon attribute, which takes the name of an icon. We're assuming this app has an icon component in it, and standard Phoenix apps do. They come with hero icons out of the box. We've also added the missing target attribute that we talked about before. So now we support live components. That's cool. We can also customize the button now by passing in additional classes. It still has that baked-in class, but like now I can add additional classes on top of that if I want to. And importantly, we've decided to remove the label attribute and replace it with the inner block itself. You see, we're rendering the slot inner block. So now whatever the user passes as the inner content of the button just gets passed through as is, in addition to that icon there, right? So let's see how we use it. Looks great, right? We've got the action is now capable of being a JS command because I changed the action type from string to any. It supports the target, like I already said. It supports, got the icon that we're passing in and the extra classes. And on top of that, right, inside the inner content now, I was able to like bold and emphasize the me in there. Sorry that the screenshot doesn't match. It was supposed to, but I was running Tailwind, and of course Tailwind removes the default styling for strong and EM tags. So it's composable. You can put anything you want inside of it. It's customizable with the additional classes. We've added support for being able to use it inside live components and be able to use JS commands if we want to. But it's still not quite right? We have this icon component that's coupled in there. So like what happens if I want to use a completely different icon from a different icon set or a different icon component altogether? It's fine. You could like say, you could just not pass the icon attribute because it's optional and, put whatever you want in the inner slot. But then it's like weird. Why does the button have an icon in it? And we're also doing this other thing where we're renaming these like standard attributes. As a Phoenix developer, you're maybe used to like phx-click and phx-target. You know what they are, and then you come across this component that's like, well, I have an action attribute and a target attribute, and it's like, why? We decided to change the names. It's weird. Let's try again. So let's make a very flexible button component. Our button requirements haven't changed, but we want to build a more flexible version of it. Let's try. So just remove all the attributes. Just replace them with one global, right? We got the Atra REST global. That just passes through all standard HTML attributes that are globally available for any HTML element, as well as the standard Phoenix binding attributes like phx-click and phx-target and whatever else you might want, right? We no longer need to manually handle those click and target bindings. We've also just thrown out the baked-in icon, right? If the user wants an icon, they can just include it in the inner block. This is how you use it. I like this a lot better, right? It's nice and flexible. It's composable, customizable. It doesn't have features, right? Because it's flexible. Use it how you want to use it. It does one thing and one thing well. It's a button. So, okay, end of side quest. Let's move on to some actual graphs, right? Keep those lessons we just learned in mind as we take a look at Plox. So let's build this simple line graph. It has dates along the x-axis, and it has numbers along the y-axis. And we also want points rendered at each data point as well as a line connecting them, right? Nice and simple. Here's the code that you would put inside of a controller or LiveView callback. I'm going to go through it line by line, but I just want to say, right, I've been mentioning LiveView a lot, but I want to stress that this works perfectly fine in standard Phoenix apps. It does not require LiveView. Plox is not LiveView specific. I just chose to use LiveView for these demos and examples. And of course, the live updating, animating graphs do need LiveView. So we start at the top with our raw data, right? This came from a database or an external service or wherever. It's just a simple list of maps where each map has a date and a value, right? Nice and simple. Here we decide on the dimensions of our plotting area. In this case, we've chosen 670 by 250 pixels. There's also some built-in default padding and margins that are customizable. The margins are where you normally would render axis labels. But it's flexible. You can do what you want. Plox needs scales in order to convert the data values, like dates, to actual pixel coordinates within the plotting area, right? So here we're creating a basic date scale by giving the earliest and latest dates present in our data set. It doesn't infer this. This is like up to you to decide how you want your x-axis to be drawn. So here we give August 1st as the first date, August 5th as the last date, because those are the first and last values present in our raw data. Then we create an axis. The axis is needed to know which axis the values are being converted for. Here is where we're making the decision that the dates are part of the x-axis of the graph by using the plox.xaxis struct, right? The dimensions are given so that the axis knows the bounds of the plotting area for that axis. Same thing here for the numeric values. We're just using a Plox number scale for our data, 0 to 80. Those aren't the minimum and maximum values in our data, but that's the values that we wanted for our scale. And the y-axis to indicate that we want them on the y-axis. Now finally, we put it all together into a data set, which is where we define the mapping between the data keys and the axes they belong to. We supply little anonymous mapping functions there that tells the data set where to find the raw values for each of those axes. Now, moving on to the HEEX template. Now that we've set up the data set and axes, we can actually go about rendering our graph using the Plox function components, the HEEX components. This is where I want you to remember those lessons we learned about building small, simple, flexible HEEX components, because that's what all of these things are. The outer graph component renders the SVG frame with an appropriate view box given the dimensions. Nothing more, nothing less. And now you can watch the upper right corner of these slides here to see what each highlighted component contributes to the overall final graph. The x-axis labels component are being drawn here with this component, with our custom date formatting being passed as the inner block there. I'm also using Tailwind in this example with that class text-sm for a smaller font. But it's important to point out that Tailwind is also not required. Any other method of styling is perfectly supported. The fact that the class attribute is being passed on to the labels is just because we're using the REST global attribute and passing it on. All valid global HTML attributes and all valid SVG presentation attributes are supported and just pass through. The y-axis is being drawn here, and we've chosen a custom number of ticks. Passing in 5 here just means 5 labels will be drawn. You can customize that to be whatever you want. The next 2 components are responsible for drawing some background grid lines if you want them. So they behave almost exactly the same way as the axis label components, but they draw lines instead of labels. Here you can again see me using Tailwind to define the stroke colors, and I'm taking advantage of the dark mode pseudo class, right? So that I can support both dark mode and light mode. If we want the y-axis grid lines to line up with their labels, we also need to pass in the 5 here to say that we want 5 ticks. Apologies if the colors are too hard to see. I think the lines are a bit too faint because of the color I chose. So I think you probably can't see those lines, right? I should have chosen a lighter color. Anyway, now we finally get on to drawing the line plot. All you need to give to the line plot component is the data set, because the actual pixel coordinates were already pre-computed when we generated the data set. There are some sensible defaults at play here, but they're customizable. We assume the data set has an axis called X and an axis called Y, but if your axes have different names, you chose to give them different names, we can totally support that. It's just some attributes that you set here. I'm also using Tailwind here to control the stroke width. You can see stroke -2. But again, any other method of styling is perfectly supported, including standard SVG attributes like the stroke-width attribute or a global style sheet if you want to. All valid values that SVG supports are supported, like, SVG supports like pixels or centimeters or inches, if that's what you want. Those are just passed through and supported as is. And finally, we draw some points on top of our line. All the same things I said about the line plot apply here as well. So let's take a look at our final outcome. Look at that, beautiful. Our graphs support both light and dark mode, and it's composed of just a set of simple, flexible HEEX components. And you can see those grid lines a little bit better when they're bigger, right? Okay, so we want, let's add some features. We want our points to have a color and have a variable radius based on some new dimensions that we've just added to our raw data. Additionally, we've also identified August 2nd as an important day for some reason. I don't know why. So we want to label it as such and draw a more prevalent grid line over it so that you can see it. Let's see how Plox helps us pull this off. At the top, you can see our new raw data with the extra fields added. We've got a new intensity number, and I've added a temperature, which is one of a possible set of atom values: cold, normal, warm. Down lower, we define a radius scale and axis to convert our intensity numbers to some reasonable radius. In this case, we're just converting an intensity between 10 and 45 to be a radius between 4 and 10. Below that, we define a fixed color scale and axis that just maps our atom values to colors. That's what the fixed color scale is capable of doing. All we have to do then is add them to our dataset mappings at the bottom. You can see we've added radius and color at the bottom, and we've given them those two names. Take note of those names, right? We named it radius and color. All right. So now on to the changes to the HEEX template itself. Let's talk about the first thing there, which is the important day label. We use the x-axis label component. Note it's singular instead of plural. This just lets you draw one label at the given value, right? We've specifically passed in the August 2nd date to that component. We've also customized it to position it at the top of the grid, and we've made it red, right? Same with the x-axis grid line, which is also singular as opposed to x-axis grid lines, plural. Now we've also customized it to have a brighter color to be more visible. Now, at the bottom, you can see the changes to the points plot that we needed to make. The points plot needs to be updated to consider the color axis for the fill attribute and the radius axis for the R attribute. Those atoms correspond to those axis names that I told you to take note of in the previous slide. And also, just to demonstrate, I've also shown that you're implicitly passing in x equals x and y equals y. Those are just like the defaults, but like I said a few slides ago, if you had different names for those axes, you could customize them there. And important note, that the fill and R attributes are just the standard SVG attributes that are accepted by the circle element that's being used under the hood, right? We just hijack those attributes to make them dynamic. But other than that, we just don't mess with them and just pass them along. So let's take a look at the results. Awesome. It looks exactly like we wanted it to. So, in summary, what is Plox? Plox renders SVGs server-side, and it's composed of a loosely coupled toolkit of low-level data structures and composable HEEX components. It's flexible and customizable using any style you want. It's usable in Phoenix and Phoenix LiveView. So what's next? Well, this version that I showed off here isn't exactly released yet. It's pushed up to GitHub and under a branch called ElixirConf rewrite because that's how you do things. So stay tuned as I clean up the mess that I made while preparing for this talk and get that cleaned up and ready for release. But other than that, there's plenty of features still missing that I'd love to see, like simple tooltips. We have tooltips right now, but there's too many assumptions baked into them. So I'm like, I need to redo it and like strip out all those assumptions and just like give you the low-level tools that you want, so that like our default assumptions don't get in your way. We also need, of course, much better docs and examples. But I think the basic bones are in place, and I really like the approach, right? I think it can scale to handle a lot more use cases if we can just stick to the core ideas that we've developed here. So if you like what you see, go check out our GitHub repo. Like I said, it's a bit of a work in progress, so please be patient. And thank you all for coming. And I'd be happy to answer any questions that y'all have.